Okay, in this video, what we're going to do is we're going to show that if you have a function or the function arccotangent of f of x, so f of x is the input and the arccotangent, then the derivative is f prime of x divided by 1 plus f of x squared, and then there's a negative out here in the front. And so we're going to use some of the techniques that Patrick JMT used in his videos, just in case you were having trouble following along. And this is what I try to do in class, but there was a mistake along the way. So we'll start off by reminding ourselves that that cotangent of x, y is equal to cotangent of x, and y equals arccotangent of x. Or if you want, sometimes it's written like this. These two functions, so let's call this y1 and y2, these functions are inverses. What does that mean? Well, that means that again, this is a review of maybe what you saw in pre-calculus or algebra 2. It means that if you take cotangent of x and you plug in the arccotan inside, let's say maybe you have a u inside of that one, then you're going to get u. Or if you take the arccotangent and then inside of that one you decide to put a cotangent of u, then either way you're going to get whatever I'm highlighting back. Okay, so in this situation, the first thing I would do, since I have an arccotangent, I would say take, make each side of the equation, no, input, sorry, not make, that's what I wanted to say. Apologize for that. Input each side of the equation. Y equals arccotangent x. And in fact, I think what I was trying to do was maybe make it a little bit like this. We had room into the tangent, into the cotangent. So what do I mean by that? It means that I'm going to have a cotangent and it needs an input on the left, and have a cotangent and it needs an input on the right. And on the left-hand side, I'm going to put y. And on the right-hand side, I'm going to put this in here. So I end up with cotangent of y is equal to arccotangent u, oh, sorry, x. Oh, and apologize for this. This is supposed to be an f of x. So f of x. So right here. And so notice that this looks like the one on the left right here. And the yellow part, the part that's in yellow, I guess maybe I should have been consistent. This part, that's the f of x. So on this right-hand side, use the properties of inverses to simplify, of inverse functions to simplify. So I have the cotangent of y equals f of x. Okay, good. Now that we're there, now the next thing that we have to remember, okay, is take the derivative of both sides. So find the derivative of both sides. And you're going to have to remember that the derivative of the cotangent with, let's say, a function inside, the derivative of the cotangent is negative cosecant squared of f of x times the derivative of the inside. So here, what we're going to do, I'm going to do d dx of the cotangent of y equals d dx f of x. On the left, I'm going to use this rule that I have here. So I have negative cosecant squared of y, but then I have to take the derivative of the inside. The inside in this particular case is y, so I'm going to write dy dx. And on the right, the derivative of f is just f prime of x. And so now we just use a little bit of algebra, use algebra and trig identities to simplify or to solve for dy dx. And then the trig identity I was trying to show you in class was that if you have something like sine squared y plus cosine squared y is equal to 1, this is the one that I know. But if I divide both sides by sine squared, so I divide every term by sine squared y, this trig identity, I get 1 plus cotangent squared of y equals cosecant squared of y. So here's some of the algebra. And number 1, I'm going to divide by cosine, not cosine, this is supposed to be a cosecant squared. So I divide by cosecant squared, so I get negative dy dx is equal to f prime of x over cosecant squared of x. And then what I'm going to do is this negative that you see here, and it's not cosecant squared of x, it's cosecant squared of y. So there, it's a y, and I keep forgetting that it's a y. All right, the next thing that we're going to do is that negative. I'm going to go ahead and multiply both sides by a negative. So dy dx is equal to negative f prime of x cosecant squared y. And now I'm going to go ahead and use the fact that the cosecant squared y is equal to 1 plus the cotangent squared. So this cosecant squared y, I'm going to go ahead and replace it with 1 plus cotangent squared. Okay. All right, so we're good. The last thing to remember is that at this point, and step number 2, when I went from step number 1 to step number 2, it tells me that the cotangent of y is f of x. So I'm going to rewrite this one more time, this answer that I have here. So this one is equal, you can think of it as negative f prime of x, 1 plus cotangent y squared. And you realize here that I can replace the cotangent of y with f of x. So this cotangent of y can be replaced with f of x. And so I get negative f prime of x over 1 plus f of x squared. And notice that that now is exactly what I wanted to show from the beginning over here. So that formula and the formula down here are exactly the same, they match. And so I did what I wanted to do. So the idea behind this, okay, this is using the properties of inverse functions to find their derivatives. So notice that I used the properties of inverse functions here, and then I took the derivative using the chain rule, and then we just used a little bit of algebra and trig identities to get to where we wanted to go. So this is something that I think is very valuable for us to know how to do when we're dealing with new functions that we don't understand. Always think about, can I use a property of an inverse function? I hope this helps. I hope this is clearer than whatever I put in the class, and I'll see you soon.